Hi everyone, welcome back to Level Up. My name is Priyanka Nair and today we will be doing the first chapter for mathematics for class 10, real numbers. Before we get started, make sure to subscribe if you haven't already. Hit that notification bell so you get a notification every time we post a video. And most importantly, make sure to share this video with as many people as you can and people you think might benefit from our videos so that you help serve the purpose of our organization and more people can know about what we do. So with that being said, let's get started with the chapter. Okay, so before we delve into the contents of this chapter, something I wanted to point out is that a lot of kids tend to hate mathematics because we don't understand the concepts while doing mathematics. And there are a lot of reasons for that, especially because a lot of us study just for the exams. However, math is not a subject that we can study just before the exams. And I'm saying this out of experience. When I was younger, in younger grades, I used to study math just before the exam and never practice it on a day-to-day basis. However, I will tell you in grade 10 that is not possible. You need to do math at least every day or at least once in 2 days. It is mandatory to stay in touch with the concepts and be in touch with the subject generally. So to tell something out of a personal experience, after grade 9 I totally hated math because it was a huge jump from grade 8 math, right? In grade 9 we did proofs, we did constructions, very different, and I hated it. I lost a lot of marks in math when I was in grade 9. However, I will tell you grade 10 math might be a little similar to grade 9 math. However, it is not as intense. Now that we've done an entire year of proofs, we do know what proofs are. We can work with it in grade 10. Grade 10 math is very interesting. I loved grade 10 math. It was a turning point for me in my journey with math. It is the kind of subject in grade 10 that the syllabus that we have are includes such kind of topics that we can't just by heart one question which we could do in grade 8. So if we by heart the method of solving one question, we can solve any other question that comes that way. However, in grade 10 we can't do that. You need to know the concepts and you need to understand the principles behind that question or the solution to that question and so on. So that's why grade 10 math is very interesting and you need to pay attention, especially in class. I know it's online, a lot of you all might tend to be distracted and not pay as much attention, but it is very important. Do use a lot of guides. Like for example, I used RD Sharma, which is very good. It has almost all types of questions under the sun. Do use that. And also I on our website I will be uploading my answer sheets, my question papers that I did for this chapter and also for term 1. So you all can take a look at that and see how the correction was done and so on for more pointers. Anyways, moving on, because we need to understand the concept, we will, before we get into the content of this chapter, which is basically operations on real numbers, we will first understand what real numbers are. So if you take a look at this picture on the right, you will see real numbers somewhere over here. But as you can see, real numbers includes a lot of things inside, and that is natural numbers, whole numbers, integers, rational numbers, and irrational numbers. So let us understand each step by step. So now when I mention the word set during explanation, it basically refers to each circle or square here is called a set in mathematical terms. So our first set and smallest set is natural numbers. Now, natural numbers are any number starting from 1 to infinity. So any number falling in that gap is called a natural number or a whole number. Now, I'll tell you where whole numbers come in. Now, if you see in this whole number bracket, only zeros here. Why? Because it includes 0 and all of natural numbers, which means whole numbers are all numbers starting from 0 to infinity. Now there's something bigger that comprises both whole numbers and natural numbers, and that is something called integers. Integers are basically also in all whole numbers and natural numbers, plus all numbers that are located on the left of 0 on the number line, which means all negative numbers as well. So from negative infinity to positive infinity, that's going to be our integers. Now, rational numbers includes integers, whole numbers, and natural numbers. So, rational numbers are all numbers where we can include decimals, fractions, all of that would be our rational numbers. Decimals that terminate at some point, all those will be considered as rational numbers. But however, if you can ask me, pi is a decimal that doesn't terminate at any point, right? It goes on and on and on, 3.14, and there are so many digits after that. So what would that be termed as? The answer to that question is an irrational number. And that is different. It's not under this rational numbers at all. It's a completely different set called irrational numbers, as you can see over here. So root 2, root 5, root 6, decimal like answers to which there is no end. Such kind of answers or like such kind of numbers would be termed as irrational. So what are real numbers, which includes both rational and irrational? Absolutely. So as you can see in the definition here, real numbers can be defined as the union of both rational and irrational numbers. So they can be both positive or negative and denoted by the symbol R. So this is a very important point to make sure to keep this in mind. Not just for grade 10, but also for grade 11, it does come in hand. Now, just a little revision. All natural numbers, decimals, and fractions come under this category, which is real numbers. And again, to revise, real numbers basically means rational numbers plus irrational numbers. That would be your real numbers. Okay, so officially starting off with this chapter, let us start off with the first theorem in this chapter, which is also known as Euclid's division lemma. It is very important to make sure to have this by heart because it could be asked as a 1 mark question as well. Now, if you see, if you notice over here, it mentions lemma. Now, what does lemma mean? This is also important. It is mentioned in the blue box in the textbook. Do make sure again it is not necessary, but it is better for just better understanding, and also because you might not want to miss out on those 1 mark questions, that you do make sure to go through these blue box in the textbook. So in one of these blue boxes, after this theorem, it is mentioned that lemma is a proven statement used to prove another statement. So in this case, this theorem states that given two positive integers a and b, then exists unique integers q and r satisfying the equation a is equal to bq plus r. But given that this remainder, which is r, is greater than or equal to 0 and lesser than the divisor. So basically we all know the long division process, right? This theorem basically is something that we've already learned in our previous years, that dividend is equal to divisor into quotient plus remainder. That's all this theorem states. Except it is very important to know this condition. Do keep this. It was even asked in my boards, what is the condition in Euclid's division lemma to satisfy this? And a lot of kids get confused with the greater than signs and so on. Make sure to keep that by heart, or at least understand the concept behind it, and you will know. You don't have to by heart this. And keep this terminology in mind. It is very important. You can lose out on marks if you don't mention the exact terms. Now, one of the applications of this theorem is to find out the HCF when we have two given numbers. So you might not understand how we can do that. So let's take an example and find out. So let's take the example of 55 and 42. So using this Euclid's division lemma, we will find out the HCF of these two numbers. Now, first of all, the first step is to take the bigger number out of the two numbers given. So in 455 and 42, obviously 455 is a bigger number, so we will take that first. Now, what we're going to do is express 455 in terms of the other number given, which is 42. So what is 455? It's 42 into 10, which is 420, plus 35, right? So for example, we'll take another example and do this later for better understanding, but I hope you understood what we're doing here. So first we take the bigger number, 455 in this case, and express it in terms of the smaller number, which is 42. So how many times 42 is equal to 455? Not, you don't get a proper number, right? So whatever number comes closest, which in this case is 10, we take that and plus how much will give us 455. So 42 into 10, 420, plus 35 equals to 455. So that's our first statement. Now what we're going to do, take the first number that is over here, so which is in this case is 42, and write that as your next. So basically what we're doing is taking the biggest number of every equation and putting it as our next equation. So in this number, we will take the right hand side of the equation and take the biggest number from here, which is 42, and put it on the left hand side of our next equation. Now 42, express it in terms of the second biggest number here, which is 35, or the remainder basically from your previous equation, and express it in terms of that. Now 42 is equal to 35 into 1 plus 7, right? Now write that down. Now again, since we're going to continue doing this process, until we get 0 as a remainder on one of the equations. So again, here our remainder is 7, so we have to continue. Now on the right hand side of the equation, take the biggest number, which is 35. Write on the left hand side of our next equation. Now 35 is equal to second biggest number here, or the remainder, take 7 and express it in terms of that. So 35 is equal to 7 into 5. We all know that 35 is a multiple of 7. So it will be 7 into 5 plus 0, which in this case means that 0 is a remainder. So we can stop here. But now you might ask me, now how do I know the HCF from this? So basically, the biggest number on the right hand side of our equation on your last equation, which means the equation with 0 as a remainder, the biggest number in that equation on the right hand side of it will be your HCF, which means here 7. So any number in this position, which is here, is going to be your HCF. So any number in this position, which means the number just after the equal to sign in the equation in which 0 is your remainder, will be the HCF. Okay, so for better understanding, let us take these two examples and solve it. So now in our first example, 135 and 225, again, as I said earlier, our first step is to take the bigger number. So out of these two numbers, 225 is our bigger number. So we'll take that and write it down. Sorry about my handwriting, I'm using the PPT pen, so please bear with that. Anyways, now we have to mention or express 225 in terms of the smaller number in this case, which is 135. So how many times 135 is equal to 225? You're not going to get a right number. So the biggest number plus the remainder, we're going to write it in those terms. So 135 into 1 plus 90 gives us 225, if I'm not wrong. Now we will take the bigger number out of this equation on the right hand side of the equation and write it down. So in that case, it is 135. Now write down 135 and express it in terms of the second bigger number in this case, which is 90. So 90 into 1 plus 45 gives us 135. Now again, we take the bigger number on the right hand side of the equation and write it down, which is 90, and express it in terms of the smaller number, which is 45. So how many times 45 gives us 90? Here we get an exact whole number, 2. So 45 into 2 plus 0 gives us 90. So now, as I said, when we get 0 as a remainder, we stop, right? So since we got 0 here, we stopped, and the biggest number on the right hand side of the equation on your last equation, or basically the number in this position, is our HCF. So the answer to this question is the HCF of 135 and 225 is 45. As simple as that. Now let us try the next question, which is 196 and 38220. So again, we take the bigger number, which is 38220, and write it down. Oops. Excuse that, that's a 0. Okay. So we take 38220 and express it in terms of the second smallest number, like the next number, which is 196. Now, I know this is a pretty big number, but if you do your calculations, you will understand that actually 196 is a factor of this number 38220. So 196 into 195 plus 0, because it is a factor, and 38220 is a multiple of 196. Our remainder will be 0 in this case, which means that we just have one equation. Again, you can either point it out this way, that we take the biggest number on the right hand side of the equation, which is 196, or any number which comes just after the equation, like the equal to sign in the equation with 0 as a remainder, will be our HCF. So again, 196 is our HCF in this case. So that's all. It's a very easy concept and very easy to score marks. So make sure you guys don't lose out on marks here, because I remember in one of my exams I lost marks because I got my calculation wrong, which is very sad because it's such a very simple concept which anyone can grasp hold of very quickly. So make sure to do your calculations right. And that's all for this concept. We will move on to the next concept now. Before moving on to this concept, however, I think it's better for all of you all to pause the video here and try out these practice questions. If you're not able to do it or you're making a mistake, make sure to go back, watch the video part where I explain this concept again, and then move on to the next concept. So be thorough with this concept, and as practice questions, make sure to try out these questions. They are pretty, like the third question exam, like in particular, is pretty higher level, or at least higher level for this concept. Try it out and make sure you're getting it right. If not, or if you have any doubt, make sure to put your doubt below in the comment section. Moving on to our next theorem, which is a fundamental theorem of arithmetic. So this theorem basically states that every composite number can be expressed as a product of its primes, and this factorization is unique apart from the order in which the prime factors occur. So basically it states that every composite number has a unique prime factorization. For those of you all who forgot what prime factorization is, it's something we did visit in our previous, when we were in grade 7 and 8. As you can see on the right, it's probably not, yeah, as you can see on the right, prime factorization of 980 is given as an example. This is how we do it. We take prime numbers, for example, the smallest prime number, which is 2, and divide it, and we get 490. Now 2 goes in 490 as well, so put 2 again, and we get 245. Now the next prime number, smallest prime number, which goes in 245, is 5, and do it so on until we get 1, as in no longer it can be divided by a prime number. And therefore 980 in this case can be expressed as a product of its primes, which is all the numbers on the right hand side. And the questions that can be given as part of this subtopic is: number one, state the fundamental theorem of arithmetic. Very important, in fact, even I think even more important than the previous theorem. Make sure to know this by heart for sure. And another question that can be asked is finding the HCF and LCM using prime factorization. So I am not going to be revisiting that because I'm sure each one of you all already know how to find the HCF and LCM using this method. If not, just go to the textbook again. It's given very clearly. Try doing exercise 1.2. All questions in that very easy to understand. So HCF and LCM I will not be visiting for this method especially. However, using this throughout this chapter, a lot of questions, not just find the HCF and LCM of I don't know, of like giving two numbers. That's not the only question that can be asked. In fact, questions can be asked like giving word problems, and then you have to find out whether you need to use HCF or LCM and give the answer. So we will be doing that in our coming, like our next videos. This is part one of this chapter. I will not be able to finish the entire chapter, otherwise it's going to be really lengthy and you're going to get bored. So we finished two concepts today, and we're going to stop here. However, do make sure to check out those practice questions that I've already given in this video, and also our website where we have uploaded worksheets for this chapter. It will be uploaded soon. Make sure to check out those questions because I'm also uploading like questions from the exam point of view, what are extremely important. Again, you can practice all questions from guides, but make sure to finish every question in the textbook at least twice. Very, very important. So with that, we're going to conclude this video. Again, make sure to subscribe, hit that notification bell, comment if you want any doubts cleared, or if you have any problems in the questions or concepts covered today, or if you want any other chapter to be addressed by any other member of the team for any other subject. Make sure to comment all of that down below. Also share this video with as many people as you can, and like this video. So with that being said, goodbye, have a very safe day, and that's all. Stay tuned for our next video.